This isn't the video I wanted to make because I made a mistake. A mistake that I've been living with for the last 3 years, 2 weeks, and 4 days. That's 26,712 hours of frustrating workarounds, 1,602,720 minutes of self-righteous ignorance, 96,163,200 seconds looking everywhere but at the problem itself, thinking the problem was too big to bother until the bother became bigger than the problem, and the problem, as I would discover, was a lot smaller than I thought. Welcome back to Inheritance Machining. So the mistake. We'll get to that in a bit, because first I have to talk about the problem. This lathe is not very straight. I mean, to you it probably looks fine, but straight is a relative term in machining, and relative to my standards, it's not straight at all. The trouble with an unstraight machine is that it makes unstraight parts, so almost everything I turn with this lathe comes out slightly tapered, unless I give it a calibrated whacking. Now, a few years ago, I did give this lathe what I considered at the time a proper leveling job, but my standards have since increased, or more accurately, my patience has decreased as I'm tired of working around this wonky lathe. There are a lot of factors that could be causing this, so I'm going to start with a bar test, which is exactly what it sounds like unless you're a law student. I'm going to turn the longest bar I can and see how straight it comes out. If this lathe is all wonky, the bar should match that wonkiness, giving me an idea of where I need to pay attention. This also happens to be the largest single part I've ever turned in this machine, between centers no less. But this is necessary so I don't end up with any other outside influences like a chuck throwing another variable in the mix. I only want to look at the effects the bedways have on the carriage as it goes the full length. Ignoring my arbitrary hand gestures, it's clear there's some variation here. A pretty steep increase in diameter of about 4 thou in the first 8 inches, then it sort of hovers there through the middle and drops 1.5 thou in the last 10 inches. So a max variation of 4 thou, or about the thickness of a single human hair. A lot of people would probably say that's good enough, but not I. The good news is now we know where we stand and all we have to do is make it better. Last time I did this, I used a precision level on the lathe's carriage and moved it around while I made adjustments to the leveling feet on the ground. More important than leveling though, the feet are needed to twist and contort the lathe so that it comes out straight, something that it won't do just naturally because of its sheer weight. The trouble with my approach last time though was that the carriage is so wide it ends up averaging out the wonkiness of the bedways, making it harder to really nail down what's going on. So we're going to skip the carriage altogether and design a fixture that will hold the level for us. Even if they weren't the sponsor for this video, I'd still be using Onshape for this because I just like it. Not only for what it brings to the table, but also for what it doesn't. By that I mean crashes, updates, and data losses that plague other softwares, eating up my valuable time and cortisol reserves. Onshape, however, did something revolutionary. They just left all those problems out. They can do this because Onshape doesn't actually exist on your computer. It's completely cloud-based and runs from an internet browser, which, I'll be honest, sounded like a joke to me at first, but it just works. I genuinely don't notice a difference. So for me, it's nice to have a high-powered software without the price tag that doesn't get in the way and is accessible anywhere. Imagine expanding these conveniences to a whole team and you'll have some happy engineers on your hands. And now, for the first time ever, government contractors that require regulatory compliance like ITAR and EAR can access the same great software with Onshape Government. I highly encourage engineers and hobbyists alike to sign up for Onshape and get up to 6 months of the professional version for free at onshape.pro/inheritance machining. Alright, here's the design. There's this piece, this piece, this piece, this piece, and this piece. You know, I think it'll be a lot more fun if I just explain as I go. So let's start with this piece. It's going to basically be a long V block with some balls. Before I can add the balls, I need the V, and before I can add the V, I need a block. But of course, not this size. I'll probably never use this offcut, but somehow this makes me feel better than the alternative. Anywho, now we can buckle in for a mesmerizing massive fly cutter sequence. To make the rest of this fixture, you'll never guess what I need. A fixture. This one has a pivoting base that I can set to exactly 45 degrees, matching the angle of the ways on the lathe. Dowel pins square up the block with everything else, and clamps keep it from running off. Because of the fixture, I can easily flip this around to keep the V-groove symmetric, but this also applies to the chamfers and a set of blind reamed holes. Last is a simple set of countersunk holes for screws to mount this to the rest of the assembly. Now I owe you a little explanation. Each of these blind holes is actually a press fit for some hardened steel balls. While I made this block a V-shape to match the bedways, it would be really hard to guarantee consistent contact along the matching faces. The balls remove this problem though because they limit the contact to 4 predictable points, constraining this in 4 degrees of freedom, leaving only 3 left to consider. The linear one, which we don't want to constrain at all, this rotational one, which we definitely do, and lastly the temporal one, which I have to pause for a minute because I just got a special delivery. You see, along with the crooked lathe, I've also been dealing with a lackluster storage situation. Anytime I need a live center, I have to fish it out of a drawer. My chuck wrenches just end up piling up here, and some of my more commonly used tools are spread around the shop. I finally had enough, so I decided to do something about it and use Send Cut Send. They're a US-based custom sheet metal fabrication service that can make just about anything you can design. The order process is easy, you don't even need a drawing, you just upload your 3D models and they figure out the rest. And there are loads of materials, coatings, and other finishing options you can add. Probably best of all though is they're super fast. My parts shipped only 2 days after I ordered them. So let Send Cut Send help on your next project and get 15% off using my link down in the description. Let's get these mounted. The first one is for my tailstock tooling. Drill chucks, centers, and well, I guess that's about it. But I figured the best place for tailstock accessories is by the tailstock. Down here it will be out of the way but also within arm's reach. And after adding a few 3D printed bushings to protect the tapers, bada bing. The other bracket looks far more complicated than it is. It also gets attached to the backsplash with some fancy flanges to keep it sturdy, as if the thickness I cautiously chose wasn't enough. Seeing this in person gives me no doubt that it will serve as a stable foundation for the 2-pound DRO. And of course all the tools needed up at this end of the lathe. Finally freeing up the top of the machine. For more stuff. Man, who knew brackets could be so sexy? Anyway, we were in the middle of something. Back to our leveling fixture. The next piece is a block which, as you can predict, needs to be square. But we all know how that goes by now, so I'll jump ahead to the part where we start poking holes in it. First are 2 through holes in what I'll call the side of the block. And after tipping it over, I can mill the top of the block to its final dimension, leaving a partially revealed hole that will make sense later. But from here, it's just a bunch more holes. Some reamed, some threaded in, some countersunk. Of course it wouldn't fit in without a few of these. Then a nice big slitting saw cut to nearly chop this in half. It's going to bug me that the hole and saw cut aren't centered, but not enough to remake this. So let's add it to the leveling fixture. First, a long dowel pin is driven through the weird half-hole thingy, then some short dowels go on the top. This then gets attached to the bottom of the V-block from underneath. And a precision ground shaft that I let someone else make goes in here and is clamped tight with screws. Meaning we just have a couple more parts on this end to whip up before this whole shindig makes sense. Fortunately, we get to play with the lathe a bit this time, starting the usual way, of course, with some facing, turning, and drilling for a tapped hole. I chose an oddball tap specifically for its finer pitch, and of course I don't actually have the right drill size for that, so I'll have to bore it to the right starting diameter before I can actually use it. After centering up the other end, it also gets a hole, reamed this time. then a big old chamfer that looks cool but is also needed for clearance. The rest of this is a job for the mill. The first hole is for mounting to the crossbar of the assembly. It's also my reference for the remaining features. So for the next hole that happens to be perpendicular to this one, I can slide a gauge pin in here, then rest that on 1, 2, 3 blocks to square it up. It's a similar story for the top hole, only this time because I have to use V-blocks to square it up, I'll use the dial indicator and compare it on both sides of the gauge pin. Yet another gauge pin helps me find the center, and then it's just more of the same. Finally are the clamping slits like I did on the previous block. The first I can knock out in this setup. The second though I have to turn on its side, so I'll use the gauge pin indicator method again to make things square. Alright, just one more piece to make which screws in here. This one is all turning. And because it's a thumb screw of sorts, after getting the outside to diameter, I'll add some knurling. The stem then gets turned down to its final size and threaded to a perfect match. To do the other end, I have to hold on to the threads, and the best way to do this without damaging them is with the collet chuck. So after facing this side to length, I can add the last and final hole, and that's it. Now let's get this all together and see if I can explain what it does. I mentioned before that the 4 balls in the V block take care of 4 degrees of freedom. With the addition of these last few bits, a ball now rests on the opposite bedway, making this whole thing a steady platform for my level. And that's what the ball and pins on the top of this assembly are for. They basically give me the same constraints for the level so I know it's in the same exact position on the fixture every time. And to actually get the level, I can adjust the thumb screw on this end and lock it in place, which means we're ready to use this thing. I think a good first step is to just see where we stand along the length of this bed. But I'll go ahead and skip the part where I haphazardly took readings and jump to the more scientific part. When I cut this test bar, I took measurements every 2 inches, so it makes sense to do the same for these as well. I think it's also worth mentioning that this isn't your average level, though if you have eyes, you probably could already see that. Each of the tick marks on this level equals 0.02 millimeters per meter, or 2.5 ten-thousandths of an inch per foot, which is a mind-bogglingly small measurement. Imagine taking a level meter stick or yardstick and placing a single hair under one end. That would move the bubble on this level 6 whole tick marks. So we're really getting into the nitty-gritty here. But obviously this is important because, as you probably remember, my test bar didn't come out even remotely straight. And comparing those diameters with the level readings I just took, there's a clear connection. Where the front side of the bed is high, the bar cut smaller, and where the front side is low, the bar cut larger. This makes perfect sense too because when you look at the carriage, if this side goes down, the cutter moves away from the spindle, making a larger part. Just seeing these two sets of numbers match up is very promising. But what's still a complete mystery is whether this variation is coming from my lackluster lathe adjustment or from something much deeper. Bed wear. I had this question in mind when I made this fixture, so I can actually check this pretty easily. I'll use the inner tailstock ways as a guide to measure the outer carriage ways, which should be reasonable considering the tailstock ways probably see less than 1/100th the amount of use and wear the carriage ways do. So I should be able to measure the difference in wear between the two. Or not. Literally less than a 10,000ths difference across this span. And basically the same everywhere else, if not better, including on the back set of ways, but it's not all great. The first 8 inches or so is a little rough, and this seems to match the same crazy differences we saw in both the test bar readings and the level readings. So I definitely have something to address around these parts. But before I get to that, I want to tackle what I'm hoping is just some low-hanging fruit, that being the rest of this lathe. The variations are pretty small, so I'm hoping I can adjust these away. I'll start with the twist I was seeing. According to the level, the right front end of the lathe is reading high, so I can just lower the right front leveling foot a smidge. Perfect. But now I'm seeing another problem. Both the left and right ends of the lathe are level, but now the middle is low in the front, or maybe it's high in the back. I don't really have a good way to know, and it only just now occurred to me one small deficiency in this leveling fixture. There's no way to mount the level like this, which would be really helpful right about now. So I'm left with a decision. Either I could spend another couple days modifying this fixture, or I could just put the level right on the ways. Yeah, let's go with that. Of course, this means to use the level in this direction, the lathe also has to be level-ish in this direction, which it's currently not, so some quick adjustments are needed on the 4 feet at this end of the lathe. Of course, at the same time making sure not to reintroduce any twists that we already removed. But once I get it there, we can see what's actually going on. The left side reads high on the left, and the right side reads high on the right, meaning only one thing. The whole lathe is sagging in the middle. But that's exactly why there are 4 leveling feet on this end of the lathe. Letting the pressure off the leftmost one should let the weight of the gearbox bend the ways back up to flat, which is exactly what they do. Now the back way is level at both ends, and the front is mostly there but still drooping a hair. But since the leftmost feet are already completely off the ground, there isn't much left I can do to lift this up. Trust me, I already spent a couple hours making every combination of adjustments possible and no dice. This is as good as it's gonna get. And in the grand scheme of things, it's only about a half-thou drop in this one area. So I guess I can live with that. Or rather, I guess I have to live with that. But there's still one more area to address that I'm absolutely not going to accept. This front 8 inches. Like we already saw, this is by far the worst offending section. And I think it's no coincidence that it's the only removable section of the lathe bed. I mean, the level says it's bad, the indicator says it's bad, and I can literally feel the seam with my fingernail. So, after years of cutting tapered parts, let's see what the hell is going on. Oh. Duh! I'm no Sherlock Holmes, but I think I just found the problem. I completely forgot about this shim I've been sticking in here. I mean, in the back of my mind I knew it was there, but I never really put 2 and 2 together. When I leveled this lathe years ago, somehow I determined that this was needed to get things straight, but apparently that was way, way wrong. And it would explain exactly why I've been dealing with a taper problem ever since. Literally 3 years of trouble, and it was all my doing. I think the answer to my problem is pretty obvious now. Let's put it back together, without a shim, and see what it looks like. Okay, so that didn't completely fix the problem. The far left indicates nicely, but there's a sharp drop right at the seam. Not much though. Despite my better judgment, I tried my thinnest 1.5 thou shim on this side, and it was too much. And making it thinner wasn't an option. I don't have anything else smaller, so I had to get creative. This plastic bag sheeting isn't any thinner, but it is squishier, so I might be able to smush it down to the thickness I need. And sure enough, with the right amount of torque on the bolts and enough wax with the dead blow, that is exactly what I needed. Now the readings from the bed to the removable section are nearly indiscernible, and that goes for both the front and the back. And if the indicator is any indication, I think it's safe to say that this lathe is extremely straight now. But that doesn't mean it will cut straight, at least not yet, because there are a few more adjustments to make. The lathe spindle is adjustable and it needs to be parallel to the bed ways, and considering we just made a pretty drastic change right here near the spindle, I would bet money that they're not aligned at all. Okay, so not as bad as I was expecting, only 6 10,000ths, but we're all set up here, so might as well try to make it a little better. If you were here 3 years ago, this whole thing probably looks very familiar, including this exact hunk of steel and these very poorly accessible adjustment bolts amidst the gears and belts at the back of the lathe. But despite the hassle, after a handful of tries, I think I can say I've got it pretty dialed. Which brings me to the last and final adjustment, the tailstock. So after getting our bar from earlier mounted between centers and taking a shortcut on both ends, we can see there's definitely some misalignment, which shouldn't come as a surprise given everything else we've just shifted around. Luckily this one's an easy adjustment, or rather maybe I'm just really good at it from years of practice. Anyway, I can see there's about 4.5 thousandths difference between the ends, so I'll use an indicator to guide my adjustments, which is a matter of loosening a couple bolts underneath and using the screws on the side to shift it left to right. After one more adjustment because I realized I went the wrong way, I've got both ends bang on the same diameter, which means now we can finally turn the whole length and see just how straight we got this thing. Okay, so it's not going exactly to plan. Being as long as this is, I'm getting a lot of chatter and vibration near the middle. I tried different speeds, feeds, coolants, and even the follow rest, none of which really helped. But I did happen to get lucky on one odd pass where the vibrations only happened for a very short window, leaving the rest of the bar true to diameter. So I think this is going to be my best shot at measuring. If we just ignore the 2 outlier dimensions where things got shaky, this is literally incredible. The majority of the bar falls within about a half thou window. Half a freaking thousandth of an inch over 36 inches. That's literally 8 times better than where we started. I'm going to go ahead and call this a victory. Though it is genuinely painful to know that I've been living with a problem that I caused for so long. But I guess on the bright side, it shows I learned something, even if it took me 3 years to do it. And now I have a nice little tool I can use next time, because who knows, maybe 3 years from now I'll get fed up again and need to make this lathe even straighter. As always, thanks for watching, and see you next time.